Question 2, we're going to find the missing angles of right triangles using trig. So just like before, we're going to figure out which trig function by starting with the angle's location. So we're always looking for theta. So since theta is here, I know that this side across from the right angle, this is our hypotenuse, and this is going to be the adjacent side because this would be the opposite side. So out of sine, cosine, and tangent, I know that cosine uses adjacent and hypotenuse. So we would be able to say that the cosine of theta equals the adjacent 4 over the hypotenuse 13. So the job here is to figure out what is theta. And the way that you're going to do that is by using inverse trig functions. So if you want to figure out what theta is, you can take the inverse cosine of both sides. So I'm going to take the inverse cosine of 4/13. So taking the inverse cosine of cosine, we isolate theta. So theta equals the inverse cosine of 4/13. And so at this point, you're going to use your calculator to determine that. So we can see the cosine button is here. Above it is the inverse cosine button. So in order to hit that, it's blue. So I'm going to have to hit second cosine. So that's the inverse cosine. And what was inside? 4/13. So 4 divided by 13 and close the parentheses and hit enter, and we get 72 point, we'll round that to 1. If this isn't the answer you get on your calculator, you need to make sure to change your mode to the degree mode. It always needs to be in degree mode if we're talking about using degrees. So 72.1. So we would say theta is about 72.1 and it is degrees, so you want to make sure that you label that answer. Let's try another. Theta is located here, so that means this side would be the opposite. Since this is the hypotenuse, this is going to be the adjacent. So what uses opposite and adjacent would be tangent. So the tangent of theta equals the opposite, which is 12.2, over the adjacent, which is 9. In order to figure out what theta is, we're going to take the inverse tangent of 12.2 over 9. So again, going to our calculator, the inverse tangent of 12.2 over 9, and we get about 53.58, so we'll round that to 53.6 degrees. So 53.6 degrees. Make sure you're putting degrees when you're labeling the measure of your angle. Number 7, if this is where theta is located, over here this would be the opposite. And then across from the right angle, this would be our hypotenuse. So opposite and hypotenuse means we're going to use sine. So the sine of theta equals 6 over 7, which means to isolate theta, you would be taking the inverse sine of 6/7. So the inverse sine of 6/7 on our calculator, and we get 58.99. So if we rounded that 9 up, this is going to go to 59.0 degrees. So theta is about 59.0 degrees. We've got one question left on these notes. This is another one where you're going to have to build the triangle, keeping in mind that your right angle is always labeled C. So if it's triangle ABC, doesn't matter where A and B go, they're on either of those acute angles. C is always the right angle. So side C is 11. That's always across from angle C. So this is 11. And side B is 10. So side B is across from angle B. So this side is 10. And we're looking for the measure of angle A. So this is essentially where our theta would be. Or you can just use A instead of theta. So based on this location, this is going to be our adjacent side and our hypotenuse. We're not using the opposite. So this is going to be a cosine problem. So the cosine of, you can either use theta or you can put A in there, capital A, equals 10 over 11 for adjacent over hypotenuse. So that means theta equals the inverse cosine of 10/11. So if we go to our calculator and do inverse cosine of 10 over 11, we get 24.6 degrees. So 24.6 degrees is going to be the measure of angle A.